All right. Yeah, well, thank you everyone for being here. I'm Aaron Johnson, and on behalf of my co-authors, Torin Clark and Alex Stimson, we'd like to present our research onto predicting the likelihood of field goal success by using logistic regression. So we're going to start with a little, I guess, game or challenge and see if you can spot the differences between these two field goals. So we're going to start with one. In December of this year, the Bills were playing at Miami, and Nate Kading went up for a 45-yard kick. Fairly typical Miami weather, even for December. It was warm, sunny, calm, no winds. It was during the regular season. It was week 17. Sorry about that. All right, I apologize. So it was week 17 of the regular season, and the Dolphins were up 21-3 midway through the third quarter. Not a very high-pressure kick. So we're going to contrast this with another field goal of the exact same distance.
Should we try switching mics?
But from this picture, you can already start to tell a few differences. It was the Oakland Raiders were playing in New England. It was typical New England weather. It was cold, snowy. It was windy. This was also in the divisional playoffs. It was the postseason.
He said,
New England was down by 3 points, and there were 32 seconds left in the game. So a little bit of a more high-pressure situation. Adam Vinatieri needed to make this kick.
Yeah, just keep it, yeah.
All right, thanks. So Adam Vinatieri needed to make this kick, or the Patriots season would be over, and it would pretty much personally be his fault. So as we can see, all field goals, even of the same distance, aren't created equal. But which of these factors really matter? Which of these factors contributed to making Vinatieri's field goal more difficult than Kading's? This is the question that we strove to answer. So this has been looked at before. A number of studies have looked at the different environmental factors that affect whether or not a field goal will be successful. So people have looked at temperature, wind, the effect of altitude if you're playing at Denver, also the effect of field surface if you're playing on grass or turf, and whether or not you're playing indoors, which encompasses a lot of other environmental factors. Football Freakonomics also looked at one particular situational factor, icing the kicker. And so most of you are probably familiar with this, but if you're not, it's a technique in which a kicker is going up to attempt a field goal, and the opposing coach calls a timeout right before he makes the attempt, in an attempt to make the kicker, I guess, think more about the kick and miss it from thinking too much. So all of these studies are good, and they're an excellent foundation which we had to work from. But there are a number of limitations that we sought to address with our study. First of all, it's not clear if any of these studies tested for statistical significance. And if you don't test for statistical significance, you can't say whether an effect is actually happening or if it's just the result of random chance. And a number of these studies also average their data over multiple potentially important factors. So for example, if you're looking at icing the kicker, say you have two kicks in which the kicker was both iced. If you're only looking at that variable, you consider those kicks to be the same kick, even if one was Vinatieri's kick in the cold and the snow, and the other is Kading's kick in a warm, sunny Miami. So by looking at a comprehensive model that contains all relevant factors, that's really the only way to get down and see what are the individual effects. And so this is what we aim to do. We built a comprehensive binary logistic regression model that included all statistically significant factors, and then it would allow us to estimate the probability that a field goal attempt would be successful. So if you're not familiar with logistic regression, it's a technique that's similar to standard linear regression, but instead of predicting a continuous variable, it predicts a binary variable. And it's perfect for field goals because there's really only two outcomes. Either you make the field goal or you miss it. So our first two research aims are to look at what factors actually do have an effect and use that to quantify the likelihood of field goal success, which is analogous to the difficulty of a field goal. Then we're going to use this model to rate and evaluate kickers, seasons, and stadiums while taking the difficulty of each kick into account. And then we're going to see if we can classify field goals as that binary variable, whether it's a make or a miss. So our model used almost 12,000 field goal attempts from the 2000 to 2011 NFL seasons. We obtained all this play-by-play data set from armchairanalysis.com. And we considered the following variables, which you can see up there. We considered distance. Of course, everyone assumes that's going to have an effect. And we considered the 6 environmental factors. We do have these variables at the time of the start of the game and not at the time of the actual kick. So that's a limitation of our data set. And to kind of help get around that, we categorized our variables. So when we look at temperature, we don't say, oh, it was 43 degrees. We say it was either cold, so less than 50 degrees, or warm. And the same with wind. We say either it was not windy or windy, greater than 10 miles an hour. We also looked at the following psychological or situational variables, and these are very interesting. We looked at whether or not the game was in the postseason, whether we quantified the in-game pressure. Is this a kick that, you know, your team's up a lot, it's early, if you don't make it, it's not going to have a huge effect on the game? Or is this a kick where you have to make the kick or your team loses the game? Looked at whether you're home away and icing the kicker. So here's our model, and you can see the list of all factors that we considered. We're going to do a little audience participation now, so we're going to go through each of these factors, and if you think it had a significant effect, raise your hand. Don't be shy. You're probably not going to be seen on the video, so. Who thinks distance had a significant effect? All right, pretty much everyone is raising your hands. That's true. Distance does have a significant effect on whether or not an attempt is successful. What about temperature? Does temperature have a significant effect? All right, I see less hands, but temperature does have an effect as well. What about the field surface, whether you're kicking on grass or artificial turf? All right, some people, that also had a significant effect. So altitude. What if you're kicking at Denver, or there was a game in Mexico City versus any other city? Who thinks that has an effect? All right, I see a few more hands. That's true, that also has an effect. The thinner air up at Denver at a mile high above sea level helps the ball to travel farther. What about precipitation? All right, most people as well. Also significant. So you can sort of see a trend happening already, I guess. What about wind? Is wind have a significant effect? All right. Wind does. And for our last environmental variable, humidity. Who thinks humidity has an effect? All right, a few people. It actually, we did not find an effect. And that's because humidity is highly correlated with things like precipitation and temperature. So you already get the information that you get from humidity from other variables already in the model. But we can see that the vast majority of environmental variables and factors do matter and do have a significant influence. But what about the psychological ones? So who thinks whether or not the game is in the postseason has an effect? Anyone? Oh, at least one person. So it actually does not. So sorry. What about the situational pressure? You know, if you have to kick or the team loses because it's your fault. Who thinks this has an effect? All right, a few more people. It actually does not have an effect. We did not find an effect. I'm sorry. It doesn't mean that there wasn't one. We just didn't find evidence for one. What about whether or not the game is at home or in front of a hostile or away crowd? Anybody? Nah, maybe a few? Also does not have an effect. And lastly, icing the kicker. So it's done in games, coaches tend to do it. Did we find an effect of it? Anybody think so? A few people did not find an effect for icing the kicker either. So as you can see, while most of the environmental factors were significant, we did not find that any of the psychological factors were significant. So this is what the end result of the model looks like. I know it's a lot of math. It's not really that important. What's important is how we use this model. So we have coefficients for each variable, and then we just pick a field goal, say this one, Kading's kick. We look at what the environmental factors were, and then we plug it into the model, and the end result is a probability that that kick will be successful. So for this kick, we see that the probability of success is 77%. So now we want to look at how these variables influence the kick, whether or not they help it or they hurt it. So this is a nominal kick, which is pretty much good weather on a grass field. You can see that being in cold temperatures decreases your likelihood of success, as does precipitation. The presence of wind also decreases your likelihood of success, although not as much as the other two. We move to the other side of the curve and we start considering turf. So kicking on a turf field, we found that it actually increases your likelihood of success. But it's not the most beneficial factor. That is kicking at altitude. So kicking at Denver, because of the thin air, greatly improves your chances of field goal success. But what about when you have multiple factors? The previous graphs were just for single factor effects. What about when you have a cold game and it's snowing and it's windy? You can see here the difference between Kading's kick and Vinatieri's kick, and there's certainly a difference between the two. But how much? For 45 yards, which was both of their kicks, the difference is almost 20%. It's 18%. So that's the difference in the chance of success, and that's certainly non-trivial. So with our model, we wanted to rank kickers in seasons and stadiums while accounting for the difficulty of the kick. It's not something that's done as comprehensively right now. So we created this metric, which we call added points. And so there you can see the formula for how we calculate added points. You take the actual outcome of the field goal, whether or not it was a make or a miss, and from it you subtract the model's predicted likelihood of success. And then you multiply it by 3 for the 3 points gained from a field goal. So we'll go through an example. So if you have a kick whose likelihood is 71%, if you miss it, you lose negative 2.13 added points. And if you make it, you gain 0.87 added points. So you gain more added points for making difficult field goals, and you lose more added points for missing easy field goals. This metric allows us to assess the kicker's performance relative to an average kicker given the same opportunity. So it provides essentially a level playing field for us to rank kickers. So the first thing we wanted to look at was assessing kickers' careers in our data set from 2000 to 2011. We wanted to show the importance of ranking while accounting for difficulty by comparing our rankings to an easy ranking to make that's used a lot, and that's just make percentage. So what percentage of kicks did kickers make successfully during our time period? So you can see that ranking on the left, and we're going to see how this compares to our rankings. So we find Garrett Hartley, the #1 kicker by make percentage, decreases to number 8 in our rankings. We find that Matt Stover also undergoes a similar drop from 2 to 9. Robbie Gould from the Bears increases from 3 to 2. And we find Rob Baronis, the current kicker for the Titans, to be the #1 kicker when ranking by added points and considering difficulty. Shane Graham, maybe not so fortunate, he decreases from 5 to 17 when accounting for difficulty. On the other side of the list, I should mention, sorry, I forgot, these are the top 5 and the bottom 5 kickers in our data set, and that's what we're going to be talking about throughout the rest of the presentation, the top 5 and the bottom 5. Dave Rayner actually increases 1 at, there we go. And the bottom 4 stay the same. So you can see that there's a lot of movement between the two lists. Some players, like Rob Baronis, are underrated by make percentage. And some players are overrated by make percentage. Shane Graham, for example. So there's a lot of movement, and accounting for difficulty actually changes the rankings. So who fills in the missing spots on our list? Connor Barth comes in at number 3. John Casey from the Saints comes in at number 4. And Dan Carpenter from the Dolphins comes in at number 5. And you can see that he is greatly underrated by make percentage. He increases 19 spots between the two lists. And lastly, Steve Christie comes in at 51 on our list. So we see that ranking kickers by just make percentage isn't a good metric because it ignores the difficulty of the kick. And that's really something that we need to take into account. So here you find our list of our top 5 and bottom 5 underrated and overrated kickers when looking at make percentage. You can see that Sebastian Janikowski is the most underrated kicker on our list. So he has an average make percentage. He's a good kicker. He has an average make percentage. But when he makes kicks, he makes a lot of difficult kicks. So that's why he's underrated by make percentage. We also took a look at the top 5 and bottom 5 single seasons in our data set. And these are only full seasons with greater than 25 attempts. I want to point out some interesting things in this table. You see that Sebastian Janikowski has 2 of the top 5 seasons. Chris Brown has 2 of the worst 5 seasons. And Neil Reckers has the interesting distinction of having 1 of the worst and 1 of the best 5 seasons in our data set. Although it's good that the worst season was before the best season, so he certainly was improving. If we look at Pro Bowl selections, we find that 3 of our best 5 seasons were selected for the Pro Bowls that year. But it's interesting to note that Sebastian Janikowski, in the best year in our data set, was not selected. While I'm on this slide, I forgot to mention something about the added points metric. When we say added points, they actually have a physical meaning. They actually represent points that kicker is contributing to his team over the average. So when we take a look at the top season here with Sebastian Janikowski, he had 19.4 added points in that season. That means that he is personally contributing 19.4 points to the Raiders over an average kicker. And Kickers that have negative added points are actually taking those points away from their team. So this metric actually has physical meaning. We also looked at the seasons in which these, the years in which these seasons were achieved, and we find some interesting trends. We found that of our best 5 seasons, most of them occurred in the last 4 years of our data set. And of the worst 5 seasons, most of them occurred at the beginning of our data set. So this really begs the question, are kickers getting better? We looked at that and we find that yes, they appear to be. There is a statistically significant upward trend in added points per attempt. And of course, this begs yet another question, why? We think it's a number of factors happening. One is that we think kickers are becoming more experienced and then getting better. So this really has 2 parts. We looked and we saw that average kicker experience per season is indeed increasing. And secondly, when you add kicker experience to the model, it improves your prediction of likelihood. So these 2 factors together makes us think, okay, kickers, they're getting more experienced and they are getting better. But that doesn't seem to be the whole story. There seems to be something else at effect. Because we just took the pure season, so 2000, 2001, et cetera, put it into the model, and it did help to improve the prediction of field goal likelihood. So there's something else going on. Either better kickers are entering the league, or training techniques are improving. It's not just that there's a sort of a group of kickers that are getting better, and then they'll leave and there'll be a kicker bubble or something. There's something else happening. We also took a look at current stadiums. We wanted to see which stadiums are most difficult to kick in and which are easiest. So we find the top 5 are the most difficult. They're generally outdoor stadiums around the Great Lakes, no surprise. And the best 5 stadiums are, 4 of the 5 are indoor stadiums, and the 5th at the bottom is Denver, which of course has the benefit of being at altitude. So then we wanted to take a look and see, okay, we have this prediction of probability, and we want to see from that, can we tell, okay, this particular kick is going to be a make, or this particular kick is going to be a miss. And so we tried a few techniques for that, support vector machines and ensemble methods, 2 of the ones that we tried. We weren't really able to do this. So we were able to get the predictions of likelihood, but we couldn't take it the step to predicting make or miss. And that's just challenges with our data set. There's a high proportion of makes in field goal attempts. Coaches don't make kicks, they think they're going to miss. That's not really a good strategy. There's also a lot of inherent noise in the system. If you took a kicker out and had him kick the same kick 100 times, he's not going to make every one of those. There's human variability between the 2. So we were able to classify kicks as make or miss a little better than just predicting them all as makes, but it didn't provide a huge benefit. And probabilistic analysis is really more applicable to this data set anyway. So the fact that we couldn't classify doesn't mean that our prediction of probability is wrong. If you make 100 kicks and we say 70% of these will be successful, that's true, but we can't tell you which 70 will be successful. So how can this model be used? In a number of ways. We think it helps fans to better understand the game, and also for the media and I guess sports geeks like us, helps us to better evaluate kickers by accounting for the difficulty. The model could also be used in in-game decision making. There's a lot of factors that go into deciding when to kick a field goal. One of them being, how likely is my kicker to make this field goal? And we've provided essentially a better way to estimate that probability. So lastly, in conclusion, we looked at the factors that do influence whether or not a field goal is successful. We found there's no evidence for any psychological factors, icing the kicker, postseason pressure. We found that poor weather conditions do have an effect. They make a kick harder to convert. So it's not this type of icing the kicker that's important. Rather, it's this type of icing the kicker. Then we found that Rob Baronis has the best career in our data set, and Sebastian Janikowski has the single best season. And lastly, we found that over the last 11 seasons, kickers have been improving when you're accounting for kick difficulty. So the next time you watch a game, and maybe it's the postseason, and your kicker comes out in the snow to attempt a game-winning kick, now you know what you really have to worry about. Thank you. So we have time for questions now. I'm going to bring my co-author, Torian Clark, up. I'm not sure if there's a mic. Oh, yeah. So we have a mic coming around. I guess you can just raise your hand. And yeah, we'll take questions.
Yeah. So if you have a question, please step toward the middle and speak into the mic. So I'll just stand here for anyone that has questions.
Hi, I really like your paper, by the way. I thought it was really a good way to look at things. I actually had a question on the icing the kicker part. I saw that the p-value for it was on the around it was 0.11, which is like around 11%. Now the data kind of seemed to suggest to me, just coursing through the paper, that there might be an experience component at play there. Did you guys take a look at that when looking at icing the kicker, like icing less experienced kickers versus icing more experienced kickers?
That's a good question. We didn't actually check for that particular cross effect. We checked for many different cross effects, but we added the kicker experience sort of late to the model as an after effect, so we didn't check for that particular cross effect. So it's definitely possible that inexperienced kickers might be more susceptible to icing, and then more experienced, less susceptible, but we didn't particularly check for that.
Yeah, I was going to say, sort of the main thing we were looking at was wanted to run the model without kicker experience so we could compare them, essentially get the pure difficulty of the kick. But that's great future work that we could certainly go on and do with this.
Okay, thank you.
Okay, I'm sure you guys do this in your paper, but when presenting this, you should probably report the marginal effects instead of the betas, just so we have some interpretation as to what the impact actually is. Because when you say significant to someone outside of the statistics audience, it's just hard to know what that means. But then my question for you guys was, in ranking the kickers, why didn't you just estimate fixed effects directly and then rank them according to that, as opposed to, doing it in a second stage, essentially?
Instead of doing it in, sorry.
What you guys did is you estimated your models without putting in individual fixed effects, and then use that on an outcome variable to rank your kickers. And you could have estimated directly using a fixed effect for each kicker and then ranked by their impact on the field goal percent. So I was just wondering why you guys chose the specification you did.
Yeah, that's a good point. The reason that we did that is we wanted the differences between kickers to be something that people knew what that means. If you give some fixed effect size and Rob Baronis is significantly better than other kickers, you say, okay, he's significantly better, what does that really mean? Whereas the added points metric, you can say, for example, that Sebastian Janikowski added 19 added points in that particular season in 2009. So it gives sort of a very quantifiable, meaningful thing to fans to understand exactly how much is he better and how much has he added.
I'm going to suggest you can do the same thing with the fixed effects and then predict it out over the... You can do the same thing with the fixed effects, then predict it out over the course of the season and still calculate points added. I think that's actually probably the right specification for your method, but if you want, you guys can find me afterwards. I'll stick around.
Thank you very much.
Okay, cool.
So just from an eyeballing of the results that you showed, it looked like the results favor kickers who are known for having more leg strength. Janikowski and Baronis in particular have kicked over 60-yard field goals. Is that something that you found that there were certain player attributes with regard to like leg strength that made them more likely to be higher value kickers?
We didn't specifically test for that. One of the difficult parts is trying to figure out what, quantify what someone's leg strength is. But you're absolutely right. That was definitely a trend in our results, and that's probably due to if you have a stronger leg, your coach is more likely to let you attempt really difficult field goals. And then if you make those difficult field goals, that's really where you get large chunks of added points provided for that kicker if you make those difficult field goals.
Thanks.
I'm just wondering, in terms of like a salary cap like football, like the Packers play in a stadium that it's inherently harder to kick in, is it to their advantage to spend more money to get a better kicker, or is that something that you looked at all?
We hadn't directly thought of that. Yeah, I guess it goes either way. That in general, it's just sort of better to have a better kicker, but you need to weigh that against other factors of, could I spend that money on my quarterback, which will just let me score touchdowns?
Yeah, so like I was just saying, because a kicker is normally, it's a replacement level player across the board.
Yeah.
And, the Browns got skewered for signing Phil Dawson to a big deal. And, but in a stadium like Lambeau, would that make more sense in Lambeau in Cleveland than it would in, Denver or a dome? But
it definitely might. We obviously didn't test for this,
yeah.
But if you had identified a kicker that would be particularly good in poor weather situations, somebody who's, say, unaffected by cold, then obviously there would be some value to them.
Yeah.
Very cool.
Yeah, I think the big thing there is the variability in conditions that a kicker faces. If you're, like if you're kicking in a dome, if you are kicking for the Colts, you're kicking indoors most of the time. There's not a lot of variability, but when you get up around the Great Lakes, there's a lot more variability. So.
All right, so that's all the time that we have for questions. So please, once again, thank our speakers.